Hi everyone. In today's discussion, we shall be discussing about simple curvature. Our focus of discussion shall be on the different elements of a simple curvature and how these elements are related to one another. In other words, we shall be having derivation of the relationship so that this relationship can be used to solve problems that deals with simple curvature. Kaya bago tayo magsimula guys ay inimbitahan ko kayong i-subscribe itong channel natin para sa lahat ng uploads na gagawin natin sa series of discussions na ito ay masundan natin at tuloy-tuloy tayo nagkakasama sa ating series of discussion na katulad nito. Ang topic natin guys ay about the definition of simple curvature. Sabi dito, a simple curvature is a circular arc that is used to connect two intersecting horizontal tangents. The purpose of using simple curvature is to provide transition from one direction to another. Magbibigay ako sa inyo ng halimbawa, guys, halimbawa, meron tayong dalawang towns, that these towns are connected with straight tangents, and the tangents runs this way. Okay? Gusto kong imagine natin na kung sakali halimbawa, ikaw ay magdadrive using a vehicle from this town papunta sa town na ito. Ano kaya magiging reaction mo kapag ikaw ay nasa intersection na ng tangents nito? Okay lang sana kung medyo hindi gaanong malaki ang kurbada, ang angle between them. O kung malaki. Paano kung sharp katulad nito, katulad yan, dito o doon? So, mauobliga ka na kapag dumating ka sa kanto, maaari mag-stop ka, O kaya kung hindi ka kayanin ng sasakyan mo, baka stop, urong-sulong gawin mo para makatawid ka. Maka-change ka ng direction from one direction to another. Kaya simple curvature are used in order for us to provide smooth transition from one direction to another. And basically, with simple curvature, connecting two tangents, vehicle can change its direction at its design speed, even without reducing its velocity. Kumbaga, ang purpose niyan ay para to smoothen, kay the sharp. As you would see here, nagkakaroon ng smooth transition from one direction to another. Okay? So that there is no stopping of the vehicle as it changes its direction from one direction to another or from one tangent to another. And so there will be a smooth transition, and that's the purpose of a simple curvature. Okay? So, puntahan natin itong mga elements of simple curvature para maintindihan natin kung sakali magsosolve tayo ng problem o kaya mag-design tayo ng highway, madali nating maiintindihan paano siya i-design. So, ano ba yung konsepto at nabubuo itong tinatawag nating simple curvature? Ganito yun, O imagine natin that meron tayong isang straight tangent dito, tatawagin siya nating back tangent. Siya yung pinagsimulan ng tangent na kung saan ito ay nagkaroon ng another tangent na kung saan connected dito o nag-intersect dito. And this tangent shall be called as forward tangent. Itong point na ito, itong angle na ito, is called the angle of intersection between the two tangents. And they intersect at this point, which is called as the point of intersection or vertex of the simple curvature. Basically, curvature are started at a certain point mula sa vertex at siya tinatawag nating distance from here called T, tatawagin natin siyang PC. Diba? And from the PC, nagdodraw tayo ng perpendicular line until the location of the centroid is established. So somewhere here shall be the location of the centroid. On the other side, on the same side, on the opposite side of the tangent, okay, on the side of the forward tangent, on the same distance from PI or V, okay, which we will be calling it as PT, okay, there will be another line that will pass and perpendicular to tangent until we are able to cross the initially drawn, okay, line at PC. Ito yung ginagawa dyan. So that the intersection of these two line drawn perpendicular to the two tangents are called the center of the, okay, simple curvature. And this center of simple curvature would have a radius equal to R, okay, as well as this distance from the PT to O. And these two drawn will have an angle equal to I. And you will notice that this I is also similar to this one. We shall have an explanation on why they become equal later on. So that mula sa PC, we smoothen the tangents by drawing now a curvature. The curvature runs in that direction, right? And from the vertex to O, nagdo-drawing tayo ng isang straight line so that the intersection of this line with that of the curve shall be called as a point G. And then from PC to PT, we are also drawing a line so that we shall have okay, the long chord, so that the intersection of this line joining V and O and PC to PT is called as H. And from here, we shall have, okay, an element which we shall call, okay, the middle ordinate M. Kaya mapapansin natin, marami siyang elements at ang description ng curve ay ibinabase kung ano yung magnitude ng bawat element na nakita natin dito sa ating simple curvature. Puntahan natin itong ating elements of simple curvature. And what are they? We have the first element na tinatawag nating tangent lines. Ano ba yung tangent lines? Ito yung mga, okay, makikita natin nagbiblink sa ating illustration na tinatawag nga nating back tangent at forward tangent. These are the two intersecting tangents where the curve are constructed. Ito yung dalawang tangent na kung saan doon natin ikino-connect yung ating simple curvature. Binubuo nga siya ng back tangent at forward tangent. Alam yung back tangent? Ang back tangent is a tangent where the curvature begins. Ito yung tangent na kung saan nagsimula yung curvature. Diba? And the other one is the forward tangent. Ito naman yung tangent na kung saan yung curvature ends. Ano? Nakikita natin yan, nagbiblink siya. Oh. Ano? The second one is the point of curvature. Ano ito? Ito yung point, okay, or the intersection between the back tangent and the curvature, or the point where the curve begins. Ito yung point na kung saan siyang naging intersection ng back tangent at ng ating curvature. At ito rin yung simula ng curvature. The next point is, or the next element is the point of tangency. Makikita natin dito yung point of tangency. And how do we define it? It is defined as the intersection between the forward tangent and the curvature, or it is the point where the curve ends. Ito daw yung point na kung saan nag-e-end yung ating curvature. Next is the point of intersection or the vertex. Ito yon. Okay, nakita natin nagbiblink, ano? Okay, it is the intersection of the two tangents. Kung saan nag-intersect yung dalawang tangent, we call that as the point of intersection or the vertex. Next is the intersection angle. I, asan siya? Ito, nag-intersect dito, and at the same time, ito rin yun, ano? Later on, we shall be showing, okay, why they become equal, ano? Okay, this is also known as the central angle. It is the angle between the two intersecting tangents. It is the angle between the two intersecting tangents. Next is the tangent distance. Okay, the two tangents that are blinking in the illustration. And how do we define this? These are the distance between the vertex, mula daw dito, okay, to either the point of curvature, papunta rito, or from the vertex to the point of tangency, okay, that are located on the forward tangent. So we call this as the tangent distance. Next, we have the radius of the curvature, and as you would see it here, the two blinking ranges here. These are the distances from the O to either the PC or the PT of the simple curvature. That actually describes the sharpness of the curvature. Okay, the shorter the radius, the sharper the curve. The longer the radius, the flatter the curve. Next is the length of the curvature. It is the distance from PC to PT measured along the curve. Okay, kung tingnan natin, ito yung nag-blink na yan, ano? It is the length of the curvature is the distance from PC to PT measured along the curve. The arc length, distance between the PC and the PT. Next, we have here the length of the long chord. And what is this length of the long chord? It is the length of the line that connects PC and PT. Next is the external distance. Okay, the one that you are seeing here blinking. Okay, that's external distance. Okay, that external distance is the shortest distance actually from the vertex to the curve. Mula daw sa vertex to the curve, yun yung shortest. Kaya, and this is measured, okay, directly along the line that joins V to the center. So, from this point to that point, we call that as the external distance of the simple curvature. Next, we also have the middle ordinate. Middle ordinate is a distance from the curve, okay, from the curve to the long chord. From this point to the long chord measured along the line joining the vertex and the center of the curvature. Okay, here is the line that joins the vertex and the center of the curvature. Okay, we will be measuring the distance from the curve to that long chord. We call that as the middle ordinate or M. Next, we have the full chord. Full chord. When you say full chord, it is actually a chord whose length is 20 meters. Ito yung points, 2 points on the curve na ang distance ay 20 meters. I will show you it later on. There is actually an explanation on what is a full chord. After this. We also have the degree of curvature. That is D, Actually, this degree of the curvature is the measure of what is the sharpness of sharpness of the curvature. And this is the angle subtended by a chord of 20 meters. Kanina, pag sinabi natin 20 meters, full chord yun. Diba? So, makatuwid, yung angle that this full chord is subtending, we call that as the degree of curvature. So, pakita natin, Pakita natin. Assume natin that on the curve, there are 2 points A and B. So, tingnan natin, kunwari ito yung point A natin, nakita nyo dito, at ito naman yung point B natin. Okay? Ito yung point B. And the distance between them is 20 meters. This distance. Okay, nakikita nyo yan? This one is 20 meters. Okay. Sabi niyan, then that AB, because this is 20 meters, shall be called a full chord. Ang tawag sa kanya, full chord. And the angle that this full chord is subtending, take note, I will show it here, subtending this angle. Ayun. Nakita niyo? Pakita ulit natin. This angle that this chord is subtending is called the degree of curvature. Okay? So that is how we define the degree of the curvature. It is the angle subtended by a chord equal to 20 meters. Or ibig sabihin, it is the angle subtended by a full chord. Next, we have the length of the sub-chords, C1 and C2. Kung meron tayong full chord, meron din tayong tinatawag na sub-chords. Diba? And these are the chords whose length is less than 20 meters. Kapag ang length niya is less than 20 meters, ang tawag sa kanya sub-chord. Pero ang tanong, kailan nagkakaroon ng sub-chord at bakit mayroong sub-chord? Ano ganito yun? Okay. Ang sub-chords, okay, C1, puntahan ko muna ang sub-chords. C1, halimbawa C1. Sabi yan, ang C1 daw ay nag-i-exist kapag ang station PC is not a full station or not divisible by 20. Halimbawa ganito. Halimbawa itong PC natin ay nasa isang point na not divisible by 20. 76, 65, 48, these are numbers that are not divisible. Halimbawa, yun ang tinapatan itong station na ito. Ibig sabihin, okay, between PC and somewhere along this curve ay magkakaroon tayo ng C1. At ano yung C1? Yung C1 daw ay tinatawag nating the difference between the first full station and the station PC. Ano yung first full station? Yung first full station na tinutukoy natin, yun yung kauna-unang station after PC na divisible by 20. Halimbawa, ang pinatakan ng PC ay 45. Ang first number that is divisible by 20 after 45 is 60. Sa mga tweet, itong point na ito, natatawagin natin first full station shall become as 60. And the difference between 60 and 45, which is less than 20, yun yung tinatawag nating sub-chord. Diba? Again, sub-chord sub-1 will exist only if a station PC is not a full station. And that magnitude of C sub-1 is the difference between the first full station and that of the station PC. Ganon din ang ating C sub-2. Ang C sub-2 naman nag-i-exist kapag ang station PT natin, itong point na ito na narito, ay hindi bumutak sa hindi divisible by 20. Halimbawa, 75. Hindi siya divisible by 20. Diba? And before that 75, there is a point that is divisible by 20. Yung point na yon ang tinatawag nating last full station. We call that as the last full station. Halimbawa, ito, Ayan, meron akong P dito. Tinatawag kong last full station. Itong last full station ito, yun yung kahuli-hulihang point on the curve that is divisible by 20. And if this PT is not a divisible by 20, therefore, there between the two, yung tinatawag nating C sub-2. And the magnitude of that C sub-2 is the difference between the stationing of the PT and the stationing of the last full station. And we call that as sub-chord C sub-2. Okay? Ayun, punta natin. Malapit na, Sub-angles, D sub-1 and D sub-2. These are the angles subtended by the sub-chords C sub-1 and sub-chord C sub-2. Ang ibig sabihin nun, yung subtended angle itong sub-chord na ito, kung ito ay less than 20, ang tawag sa kanya sub-angle. Ganon din dito. If this is less than 20, ang tawag sa kanya, yung angle na this is subtending, is a sub-chord. Kaya pakita natin, Then this angle, yun, nakita natin, nagbibiling dito, is D sub-1. While this one, the other one, is D sub-2. So those are the elements of the simple curvatures. The question now is, how are we going to compute and show the relationship between the elements of the simple curvature? And let us have these elements or relationship between the elements of simple curvature. Let's start with the elements between tangent distance, radius, and the intersection angle. Nasaan ba yun? Ito yun? Ito yun, at saka yun. May relation na nag-i-exist sa kanila. Okay, ipakita natin. I'd like you to consider concentrating your imagination, your attention on the triangle PCO and B. PCO and B. Para makita natin, let us show it there with a color. And let us try to isolate that triangle so that you can easily show it. Okay, show the elements. Okay, here is our PC. Nakita niyo yung PC, Ito yung ating O. Ito yung ating V. Okay? Ito yung ating R at ito naman yung ating T. This angle is not yet known, ano? Not yet known. So let's call it this as theta. Ang tanong, can we solve for the theta? Okay, how are we going to show the magnitude of this angle theta? Okay, para makita, buuin ko muna itong, ipakita ko yung other side of this triangle. Let me show this okay, O, V, and PT on the other side. Ano, yan, pinakita ko lang. And so that this becomes our PT, pakita ko dito yung angle I. Ito yung angle, itong angle natin, ito yung okay, angle I na tinutukoy natin. Ano? Ayun, tukoy natin. So, makatwid, this angle I and this total angle mula dito are supplementary. Hence, the sum of I and this angle must be 180. But, because the two angles we will observe are equal, ito, angle ito, tsaka ito, no? Yan, tsaka itong nauna, ay equal. Sa makatwid, the difference between 180 and I will be divided among the two. Sa makatwid, this will be equal to 180 minus I divided by 2. Similarly, ganoon din dito sa kabila. 180 minus I divided by 2. Kaya kung titignan natin itong triangle na ito, PC, V, and O. Okay? We can solve for the triangle because the sum of the angles inside the triangle must be 180. So that this 90 degrees PC plus theta, okay, or this theta plus PC plus this angle which is 180 minus 1 over 2 must be equal to 180 degrees. Right? Now, if we will simplify this part, how much is that? That becomes 90 minus I over 2. And you will notice that 90 will cancel with 180. And when we simplify, we transpose this to the right-hand side equation, that becomes theta being equal to I over 2. Kaya kung ito ay I over 2, pakita ko lang I over 2 yan, ano? So, bakatwid, the other side will also be equal to I over 2. And the sum of the two will be equal to I. And that is also equal to this much. Kaya doon sa nauna kong pinakita kanina, that magnitude is equal to I. Ngayon, nakuha natin that is I. So we can now apply the function of the right triangle. Okay? Establishing the relation between T, R, and I. Okay? So, tingnan natin mabuti yan. The ratio of T over R is equal to tangent of I over 2. Di ba? Simple relation between the trigonometric function. And therefore, from here, we can solve for T. T is equal to tangent of I over 2. And this is the first relation that we shall have. The relation between TR and the intersection angle I. Puntahan naman natin itong kasunod na relationship about the length of the curvature. Okay? Puntahan natin, gamitan muna natin siya yung arc basis. Ano? Arc basis. Itong haba nito, yung daw length of the curvature. Puntahan natin itong part nito, pinakita ko lang, para sinimplify ko lang. We will consider the curve that runs from PC to PT. Ba? Dahil ito ay circular arc, okay, anong tawag ito? Okay? The length of the curve is the arc length subtended by an angle equal to I over 2. Do you still remember or recall the concept that we had in our trigo? That if we have here an arc length subtending an angle equal to R over a radius equal to, subtending an angle equal to I over a radius equal to R, therefore the arc length can be taken as the product of R and I if I is expressed in terms of radian. Therefore, here, solving for the value of LCU, sabi yan, the arc length, di ba? O this curve length is equal to R multiplied by subtended angle. In this case, it is equal to I. But that must be expressed in radian. So if this I is still in degree, we have to convert that into radian by multiplying it by pi over 180. So that this becomes, substituting that with the value, I will have LCU times, or shall be equal to R times I times pi over 180. And that is the arc length formula for the length of the curvature. So, ibig sabihin, kapag given ang iyong R, given ang I, you can already solve for this by simply multiplying that Ri times pi over 180. Diba? So, there is another way of solving for the length of the curvature, and we call that as the chord basis. Chord basis. Ano bang halimbawa? Okay. ng chord basis. Sabi dito, we will consider the curve that runs from PC to PT. Balik ko rin dating yung kanina ko pinakita, no? Pakita natin yan, no? Here is our LCU and here is the length of the curve. Diba? Sabi dito, the length of the curve can be solved by the ratio and proportion with the full chord and the degree of curvature. With the full chord. Asan ba yung full chord na sinasabi? And is defined by the angle, is defined as the angle subtended by a chord of 20 meter. Hence, pakita lang natin, no? Kunwari, meron tayong full chord dito sa ating curve. Sabihin natin itong point is A. At somewhere here we have point B. And that, okay, the distance between them is 20 degrees. So, full chord yan. Yung angle na sinasubtend nila, anong tawag? Okay, degree of the curvature. And because we are talking the same curvature, therefore, there exists a ratio proportion between the 20 and its subtended angle as to the length of the curve, and the subtended angle of the curve equal to I. And that is equal to the length of the curve is to I is equal to 20 is to D. Hence, we can solve for the length of the curve as 20I over D. Right? So that becomes our second K formula. However, okay, how are we going to solve for D? Diba? Kinakailangan naintindihan natin ano man yung value ng D. Okay, so we established here the relationship between the radius and the degree of curvature. Establish natin yung radius at saka yung degree of curvature. Paano yun? Okay? Di ba, gamitin natin yung formula na derive natin about the length of the curvature. Meron tayong una, the length of the curvature is equal to R times I times 180 over pi. Ito yung length of the curvature using arc basis. Dinerive natin kanina. Tapos ngayon lang, dinerive natin yung length of the curvature. That is equal to 20I over 2. And let us call this as our equation 2. If the two equations shall be equated because they both equal to length of the curvature, therefore, R times I times pi over 180 shall be equal to 20I over 2. D. You will notice that I will cancel, ano? And that you can solve for D by simplifying, and that you will be getting R equals 1145.916 over D, or D is equal to 1145.916 over R. Ito yung dalawang relationship between D and R. So if you're given R, you can solve for D. If you're given D, you can solve for R. Diba? Ngayon, pag nasolve natin yung D, D, pwede mo nang balikan yung kaninang equation natin for the length of the curvature to get the value which can be computed by 20 times I divided by D. Okay? So, puntahan natin yung next element. Yung length of the long chord. Asan ba yung length of the long chord? Ito, di ba? Itong kulay yellow, nakikita natin. Okay. Paano siya i-derive? Okay. Now, we consider this triangle PCO and PT. Okay. Asan yun? PCO, PT. Para makita natin mabuti, ipakita na nga naman yung triangle and then i-isolate natin dito sa banda rito. Okay. So, ito yung ating PC, ito yung ating O, at yan yung ating PT. Okay. Sa gitna, makita natin yung H. Yun yung intersection of the PC and the line drawn from V to O. Kaya yan yung ating H. Kaya lang lumalabas, yung length of the long chord natin is divided or bisected. So that this becomes C over 2 as well as the other one. And that also the angle is bisected, that this becomes I over 2 as well as the other one. And that this distance is equal to R. Now, do you see this triangle? Tingnan natin yung triangle, no? PC, O, and H. And that is actually a right triangle. So, we are going to apply. Tanya natin, pinakita dito, nilinaw na. We're going to apply the functions of the right triangle, the ratio of the opposite side of I over 2, which is C over 2, to the hypotenuse R is equal to sine of I over 2. Now, if this will be simplified and then solve for the value of C, we can solve C equal to 2R times sine of I over 2. Ito, meron man tayong isang na-derive na relationship. Okay? Pang-ilan na. Siguro pang-apat na wari, ano? Next, puntahan natin itong external distance, E. Asan siya? Ito yung nagbibilik na yung sa taas, ano? E. Yun. Medyo marami-rami na itong nakikita dito. Medyo simplify natin ulit yan. Ano? Pakita natin. Consider natin yung triangle PC, O, and B. Balikan natin to PC, O, and B. So, balikan lang siguro natin yung kainang ginawa natin. At this time, ay ilabas ulit natin. So, lagyan natin ng element yan. Ito yung PC, ito yung O, ito yung V. Ito yung R, and this is the I over 2, hindi ba? Ngayon, ipakita natin itong curve. Okay, where's that curve? The curve is somewhere there. Ayun, nakita natin draw, umuhit dyan. And at the end of the curve, meron tayong point G. Ito yung point G nakita natin dito. And the distance from V to G, yun yung ating external distance E. Diba? And so, okay, you will notice that this distance from G to R, G to O is also equal to R. Diba? Ngayon, din natin dito. Gusto ko tingnan nyo yung triangle na nabuo. Okay? Triangle PC, O, and V. Diba? Triangle PC, O, and V. That is actually a right triangle. Where R is the adjacent side of I over 2. And the distance V to O is the hypotenuse. And the distance B to O is the sum of E and R. So that the ratio of R to E plus R is equal to cosine of I over 2. Ba? And we are to solve for E. Pag sinimplify natin itong E na ito, what will happen? Okay, cosine of I over 2 is equal to R plus E. I just cross multiply that part. And then I solve for E, what do I have? E becomes cosine of I over 2 minus R. Yan ngayon yung ating next formula. The formula for the external distance of the simple curvature. Next, we have the middle ordinate. Ito yung nagbiblink dito, di ba? Nakita niyan, nagbiblink. Medyo punong-puno ulit kasi ito. Gawan ulit natin ng simplify ulit natin the same triangle. Medyo ihiwalay ulit natin yan. Ipakita natin ulit yung kanyang element, P, C, O, and B. Ito yung R. This time, gawin ulit natin yung I at ipakita ulit natin yung curvature such that there is G. So we have to draw this line. The line that joins PC and PD, or the length of the long chord, pero putulin natin hanggang dyan lang. Anong point ito nakikita natin dito? This is point H. Ayun, di ba? And this distance from G to H is the one that we are looking M, or the middle ordinate. Now looking at this figure, you will notice that the distance from here up to O is how much? Is the difference between R and the middle ordinate. Diba? Kaya makikita natin dito, meron tayo nakitang triangle dito na buo, no? Right triangle. Do you see the right triangle PCOH? This one. PCOH, and that is a right triangle. Diba? If we will be using the function of right triangle with this RM as the adjacent side and R as the hypotenuse, therefore, the ratio of R minus M to R is equal to cosine of I over 2. And we are targeting the value of M. So we simplify. That is, R minus M shall be equal to R cosine of I over 2. So that, solving for M becomes R, minus R cosine of I over 2. So meron man tayong isang nabuong equation of formula. Okay, next, puntahan naman natin itong, stationing of the point of curvature, stationing daw nito. Paano kinukuha yung stationing nito? Okay? So, basically, stationing of the point of curvature is just the stationing of the vertex. This one, kung ano man itong vertex na ito, ibabawas lamang natin itong tangent distance na makukumpit natin. And that is, stationing of the BC is equal to stationing of the V minus tangent distance. What about the next? Stationing of the point of tangency, or station PT. Here, medyo meron akong ipapaunawang mabuti sa inyo. Station PT is equal to station of PC plus the length of the curvature. I'd like you to take note here that station PT is not referred from vertex. Hindi siya ginagamit, inire-refer mula sa vertex. Rather, it is taken from the PC by adding the length of the curvature. Okay? Punta natin. Length of the subchord C1 and C2. Kanina pinaliwanag ko na ito. C1 and C2 are what? Okay, the difference between first full station minus station PC. C sub 2 is, okay, station PT minus the last full station. Okay? Sub-angles, D1 and D2. Ano ba yun? These are the angles subtended by the sub-chord. Consider natin yung PCO. PCO as the first full station. Yan. Consider natin dito yung PCO at isang first full station on the curve. Ano? Kunwari, nag-drawing tayo. No? Ito yung ating PC. Ito yung ating, itong point na ito is a first full station. Kunwari, itong A. Dito yung A natin, ha? So, this distance will be C sub 1. Yan. Pakita natin. Yan, C sub 1. Kaya yung kalahati niya will be C sub 1 over 2. Okay, the distance from PC to O will be equal to R, and the angle subtended will be D sub 1. Kapag hinati natin yan, will be D sub 1 over 2. Okay. So, nakita natin that this is actually a right triangle where we can establish the relationship between C1 over 2, R, and this angle, D sub 1 over 2. Opposite over the hypotenuse of this angle, and that is equal to, okay, C1 over 2 over R is equal to sine of D1 over 2. And so, simplifying natin yan, D1 over 2 is equal to arc sine of C1 over 2R. And because we are working on D sub 1, therefore, D sub 1 is equal to 2 times arc sine of C1 over 2R. That is our, okay, sub-chord formula. And because, okay, the same is true for the other chord, then this sub 2 can also be computed using the same pattern, that D sub 2 will be equal to 2 times arc sine of C sub 2 over 2R. So, that is our discussion for today. We just have discuss the simple curvature, the elements, and the relationship between the different elements of the simple curvature. Again, I would like to invite you once more to subscribe to this channel so that, as we go on with our series of discussion, you are able to follow our discussion and be notified of my next upload. Once again, thank you for watching.